Given A, the 2 by 2 matrix with entries 5, 7, -3, and 0, and B, the 2 by 2 matrix with entries 1, 2, 9, and -1, find the products AB and BA. What does this suggest about whether or not matrix multiplication is commutative? Let's start by finding the product AB. We know that we can multiply these two matrices because the dimensions match up. In particular, the number of columns in the first matrix is equal to the number of rows in the second one. We have a 2 by 2 matrix times a 2 by 2 matrix. Because the number of columns in the first matrix equals the number of rows in the second, we can multiply them, and the result is going to be a 2 by 2 matrix. Now we just need to find the entries in this 2 by 2 matrix. First, we take the first row and we take the inner product of that with the first column to get the first element. So we've got 5 times 1, which is 5, 7 times 9 is 63, and 5 plus 63 is 68. Next, we need to take the first row times the second column. 5 times 2 is 10, and 7 times -1 is -7, and 10 plus -7 gives us 3. So that is the next entry. Next, we move to the second row, and we take the inner product of the second row and the first column to get the element down there. So -3 times 1 is -3, and 9 times 0 is 0. When we add those, we get -3. And then finally, we take the inner product of the second row with the second column for the last element. -3 times 2 is -6. 0 times -1 is 0, and when we add those, we get -6. So this is the product AB. Next, we'll look at the product BA. In this case, we have to switch the order of the two matrices. Note that the dimensions are going to stay the same, so we can still do this product, and we should still end up with a 2 by 2 matrix for the result. So to get the first entry, we take the inner product of the first row and the first column. 1 times 5 gives us 5, and then 2 times -3 gives us -6. 5 plus -6 is -1. Then we move to the next column, but the same row. 1 times 7 is 7, 2 times 0 is 0, 7 plus 0 is 7. Next, we move to the second row, and we look at the first column. 9 times 5 is 45. -1 times -3 is +3. 45 plus 3 is 48. And then we move to the last row and the last column. 9 times 7 is 63. -1 times 0 is 0. 63 plus 0 is 63. And so this is the matrix we get when we take the product B times A. And we're asked, what does this suggest about whether or not matrix multiplication is commutative? Well, here we can say that AB is definitely not equal to BA, and so we know that matrix multiplication in general is not commutative. This means that if we're asked to calculate a product of matrices like AB, the order matters, and we can't switch the order to do BA. Now, a quick note, there are particular matrices where, by coincidence, A times B is equal to B times A. This doesn't mean that that will never, ever, 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 ever happen. It just means that this is not a rule that happens all the time. It's not something that we can use, and we're not allowed to switch the order of the matrices when we're taking a product.